folks. We are in Unit 17, that is quadratic functions and equations. Our goal is going to be to learn how to solve these quadratics. If we remember our 4 different methods we have. First one was factoring. Second one was square rooting. The third was connected to the second one, which is completing the square. And the fourth is the quadratic equation. Okay, so these are the main ones we're going to be looking at. We have already covered the essence of factoring, so we're going to skip on back to page number 15. You should work on these practices over here by yourselves. Just to start you off, so you want to use the ZFP, the zero factor property. So the first step is you want to, so step 1, you want to set the equation, or step 0, set the equation or slash quadratic equal to 0 and solve. And the first step really, step 0, is then we're going to factor it, right? So if you notice over here, question B is not equal to 0. So what we're going to do is we're going to do that. So we're going to first, we get x times the quantity x plus 1 equals 6. Subtract 6 from both sides. We get x times x plus 1, the quantity, minus 6 is 0. And if you notice, that doesn't really look like a quadratic, but that's okay. What we do then is you want to make it expand it out. So we get x squared plus x minus 6 equals 0, and you can take it from here. Okay. On the next page, over here, question C. The same kind of a thing. You're going to first, step 0, set it equal to 0. And step 1, then you're going to factor and solve. Okay? And again, just to model, the first step is going to be set it to 0. So I'm going to move this stuff over here by adding the opposite. These cancel and I get 0 on this side. And then what happens on this side is we get x plus 6 times x plus 2 minus 2x minus 7 equals 0. And we do the same thing, you distribute it. Okay? You do the same thing with question D. Alright? On page number 17, you should practice these as well. And this is just practicing your factoring. Okay? It's very important to get your factoring down. You need to be good at it. Most of it should be okay, but you should have no problems doing E, questions E, F, and G as well. Okay? This is the second method over here. This is the method of square roots. So this is the second method. Or let's say method 2. Okay? So really, what does it mean? So our goal is to turn any quadratic into a perfect square. That's our goal. So if we remember over here, what's a perfect square? So for example, 64 is 8 squared, 121 is 11 squared, 9x squared is 3x, the quantity squared. This one over here, x squared plus 6x plus 9 is x plus 3, the quantity squared, and this is x minus 1, the quantity squared. And so really, your goal is to recognize these perfect squares in their form over here. Okay? It's kind of where we want to go with this one. So you should be able to do this one fairly quickly. X squared plus 12x plus 36. Can you write that as a square? Okay. Down here, we already went over this last unit. Ignore that. So over here, we've already touched on this, solving with absolute value. This is essentially, just recall, right? If you have, for example, the absolute value of x equals 5, you know x is 5, or x is negative 5, okay? So the same thing applies when you're taking the square root of some value squared. So for example, down here, example 4, what is it talking about? If you have x squared equals 9, you want to apply the square root to both sides, okay? But if you do that, these cancel out and you get x is 3. But if you remember, this is a problem, right? What's the problem? We don't know what x is. So if we remember, when we didn't know what x was, if it was positive or negative, and because the index is even, we put an absolute value there, right? So you get, solving this, you get x is 3, and also x is negative 3, okay? So that's why there are 2 values. If you notice, what squared gives you 9, what value squared is 9, that is going to be 3 and negative 3. Okay, and this basically goes down the entire process here of what that looks like. All right. Example number 5 is going through the same kind of a thing here. Okay, I'm going to work out one of these. So we get x plus 5, the quantity squared, minus 8 is 0. Now if you notice, in this case, it's already in a perfect square, right? Because you have the square. Our goal is eventually to work that out. Anyway, so what do? You want to isolate the square. So we're going to add 8 to both sides. So what I'm doing right here is I am isolating the square. Okay? So what do I get? I get x plus 5, the quantity squared is 8. Okay? And I square root both sides. Because I don't know what x is, I have to put absolute value of x plus 5 is square root of 8. If I get rid of the absolute value, that I need to put plus or minus root 8. Okay? This is exactly the same thing that we did over here, right? The only difference is I didn't write it out. I wrote it out differently. If I get rid of the absolute value, you put plus or minus 3. Okay? So when you drop the absolute value, you put plus or minus. Same thing we're doing here. And I'm going to move it over to this side. So I have x plus 5 equals plus or minus root 8. And then I subtract 5 to both sides. That's 0. So x equals plus or minus square root of 8 minus 5. But remember, we have to simplify square root of 8. And we should all know by now that that is the square root of 4 times 2, which is 2 root 2. So then I get x equals plus or minus 2 root 2 minus 5. That's my answer. Okay, so notice over here, this answer is written in a condensed form here. What you could also do is you could write it out separately. So each answer is x. One of them is plus root 2 root 2 minus 5, and the x is minus root 2 root 2 minus 5. Okay, so here's the condensed form, and there's actually the other written form of it. All right. And this is exactly what's kind of happening here. We work this solution out. The same thing is true over here for example number 6 if you have imaginary solutions, which we will work out. We'll do an example of that. Let's just do example 6. Should we do it? Let's do a practice. Yeah, let's do a practice one instead. So notice over here, so for this classwork here, which you should work on, so you want to work on the method of square roots. Okay? So what do you want to first do? You want to isolate the square root. That's kind of step 1 with this. Step 2, you want to take the square root of both sides. And then you want to solve. Okay? So just to model here, so for question A, what do I do first? Well, I add 9. You might notice this actually factors. Okay? So all of these methods work, but in this case we're doing it by square rooting, so we get 4p equals 9, and then divide by 4, and then p squared equals 9 over 4. Now what? I take the square root of both sides. I get p, absolute value p, don't forget absolute value when you take the square root, equals 3 over 2. Square root of 9 is 3, square root of 4 is 2, and then p equals plus or minus 3 over 2. Okay? Right? Or we can write this as p is 3 over 2 and p is negative 3 over 2. Okay? Cool. Question B, I want you to look back in the beginning, look back at the first page of this hint, write it as a perfect square, and go from there. Question C, I will do this one, and I'll leave the rest to you. Notice I'm going to, again, do step 1, we're going to isolate the square first. So what do? I'm going to subtract 32 to both sides. These cancel. I end up with s plus t, the quantity squared is negative 32. I take the square root of both sides. These cancel out. I get the absolute value of s plus 7 equals negative 32, square root of 32. I'm going to do this off to the side over here. So this I'm going to do on the side here. And I say, okay, so this one here, when we know the negative comes out as our friend I. And now we have to deal with the the square root of 32, and we have to work this out. So, okay, how many copies of that? It's 2, 2, 2, 2, right? Because the index is 2. So what does that mean? We have 2 copies of 2 that can come out. So that means one of each copy comes out. So we end up with I times 2 times 2 times root 2, which gives us 4I root 2. That is what goes here. We replace that. Okay? So you have to simplify your radical. So we're using our last unit for this. So what we get is we get absolute value of s plus 7. Quantity is equal to 4I root 2. Now I'm going to get rid of the absolute value. So that means I get s plus 7 equals plus or minus 4I root 2 minus 7 minus 7. If you notice, I'm putting the minus 7 not underneath because they're not like terms. These cancel. And I get plus or minus 4I root 2 minus 7. And that's what s is equal to. Okay? We write it out nice. Plus or minus 4I root 2 minus 7. Or you can write it out separately, which is s is plus 4I root 2 minus 7. Or s is negative 4I root 2 minus 7. These are my answers here or here. Both are correct and appropriate. Okay? You can go ahead and do question D. Make sure you do B. So this over here, completing the square, is directly connected to what we were just doing. So what you're basically going to do right now is you're going to change any kind of quadratic into a perfect square. So how is this done here? Well, if we remember some of our perfect squares, so our goal is to make some kind of perfect square here, right? So if you remember from before, we have these tiles, so that's x squared. Each of these is 4x, okay? So if you fill it over here, what you get, I'm going to put them in this little shape over here. So what happens here? I'm going to kind of squeeze them in, right? And if you notice, my goal is to make a square, right? A whole square, and I don't have a square. If you notice, I'm missing some stuff. What am I missing? I'm missing actually 4 ones. So what I need to do is I need to add in 4 little boxes, right? If I add these in, then I make a complete square. And so that's basically what I'm doing. So if I add those in, there, now I have a complete square, and this can be written as x plus 2, the quantity squared. If you're not sure why, write it out. This is x plus 2 times x plus 2. Multiply this out. We get. Okay? So notice, so our goal is to make a perfect square. And that's essentially what we're doing here. Let's turn it on over to the next page. You can skip this stuff down here. So in the same sense, so how do we make this kind of perfect square? Well, and again, you can construct this with tiles if you want to. I'm going to do just one more with tiles. So here's x squared minus 6x. So I'm going to put 3 here. I'm going to put 3 here. And because this is negative, these are shaded. Okay? So what does that mean? What am I missing? Well, let's draw it in. Can you tell how many little singletons are missing? We are missing 9 of these. So we're going to add them in. We're going to add 9. And then what does that give me? You can see that it gives me here x. And that's 3. X. That's 3. So what is this breaks down to x minus 3. So this is a perfect square, and it's written as x minus 3, the quantity squared. Same thing here, and we get the idea, right? So there's x squared, and then there's 8x, so that's 4. I'm going to do 4 on each side. So if you notice, I'm always taking half of it. Half of that is 4, and then that ends up being the amount that I need to complete this square over here. So if you notice, I have 4 by 4, so I need to add in, this is missing 16 of these guys, so I need to add in 16. But that's the same thing as adding the square of that number, right? So if you notice, this number was 8, and what I did was I broke those up into 4 halves there, and then each of them gave me the perfect square that I needed eventually. The same thing here, there were 6, that means I broke it up into 3 and 3, and then what was missing was the square of 3, right? Because 3 squared is 9. The same thing, half of 8 is 4, 4 squared is 16, and this becomes x plus 4, this quantity squared. So, the question is, how do I find this missing term in general? What you do is you take half of b and square it. Oops. Okay, and you want to add it to both sides eventually. We're going to do that next over here. So the same thing is true. Over here, you take b, which is 20, divided by 2, and you square it. What do you get? Well, that's 10 squared is 100. So we get 100. And then what's it going to be? X plus. The question is, what goes in there? And if you think back over here, well, what went in here? This was 4. 4 was the number of the length of this over here. What went right here? Minus 3. There were minus 3 tiles on this side. Okay? So, well, what's going to go here? I don't have a picture, but I do know it's half of whatever this value is here. Right? So half of 20 is going to be 10. So it's the value that you get before you square it. After taking half of b, so it's going to be 10. And it was positive 10, so it's there. Same thing here. We go negative 24 divided by 2, we square it, and we get, what is that, negative 12 squared, and we get 144, so we put 144 here, and then that gives me x. So there's a perfect square now, it's a perfect square. How do I write it as a perfect square? What did I take half of? What was half of b? It was negative 12. That's what goes in here. Okay? And this is exactly what it is. You take half of b and you square it, and that will give you the value of it. Okay. Turn over to over here, page number 25. Okay. So now you should work on these here. I'm not going to do these. It's not too bad. Mind, if, like for question B, if it's a fraction, it's not that bad. You just have to remember to do it out. So for example, I'll do this one. So minus 3 over 2 squared gives you 9 over 4. So that what goes here. And then I'll let you fill this part in here. Okay? Skip question C. Do questions A and B. Alright. So when you solve it by completing the square, all you're doing is you're applying both methods that we've learned. Okay? Which is the following. You're going to first complete a square. Then you're going to take the square root of both sides and solve for it. Okay? So I'm going to do example number 13 here. Take notes on the side or on a separate sheet of paper. So you want to first do the following. So mind you, we're going to solve by completing the square. Okay? So our first step is what? Well, we want to first, our goal is to make it look like this, right? And then maybe you'll have plus or minus something, and then it's equal to 0. That's kind of our goal, okay? So how do we do that? Well, first thing we're going to do is we're going to write it out like this, and we're just going to say plus blank plus 15 equals 0. So notice all I've done is I've added a blank in here. Why? Because I want to figure out what I have to do to add to this to make it a perfect square. The plus 15 is still at the end. That's totally okay. I don't need to change that. And it's the same problem still. So now we figure out, well, when I take my b, so b is negative 8. What do? I do half of it. I square it. What do I get? 16, right? Actually, let's do it out. So it's going to be negative 4 squared, and that's 16. So what goes in the blank? 16 does. And then we're also going to put a plus blank on this side because we need to add it to both sides over here. We're going to put 16 there. Okay? Why? Because what I add to one side, I have to add to the other side. And then we're going to move it down. So I have x squared minus 8x plus 16 equal, plus 15 equals 16. Okay? And now what? What do? I put a parentheses around my squared term. I write it as a perfect square. So that's going to be something squared. It's x. And what was half of b before I squared it? It was negative 4. So that's the number that goes in here. Okay? Now what? Now I just solve it. So now notice I have my goal. So I've achieved my goal because that's what it looks like. Now I'm going to solve. Okay, so how do I do that? This is like solving this for perfect squares. I want to isolate the square root. How do I do that? Well, I first subtract 15, both sides. Okay? So then it gives me x minus 4, the quantity squared, equals 1. Take the square root of both sides. That gives me x minus 4, absolute value equals 1. The square root of 1 is 1. I get rid of the absolute value. That gives me x minus 4 equals plus or minus 1. And now I add 4 to both sides. Notice I'm not adding it because there's two things happening here. Okay? So then I don't put it right underneath. So I get x equals plus or minus 1 plus 4. Or, I'm going to write it separately. I have 1 plus 4. That's one of the answers. Or x is negative 1 plus 4. In this case, notice, in all of the other cases, we couldn't simplify. I actually can now. 1 plus 4 is 5, and this is 3, so those are my answers. Okay, so notice, if you can simplify it, you don't want to leave it like this, so if you left it like this, it would be marked incorrectly. Okay, and lo and behold, let's check our work to see if it's correct, and boom, this is what they have here. Okay, so that's essentially what we're going for. Okay, so you want to use that same kind of technique for all of these here. So we're going to skip all these examples here. Okay. So that was solving by completing the square. Okay. What we want to do now is, so for your classwork here, let's skip these here. What I want you to do is solve A by completing the square, and then you're going to solve C by completing the square, and don't forget to set it equal to 0 first. This is the first step you should do. So I'll set this up for you here. So you get x squared plus 2x plus 35 equals 0. So now it's set up to, so go ahead and solve that one by completing the square. Okay? Okay. Lastly, over here is the quadratic equation, or the quadratic formula. Everybody, most of you should know this. It's going to be x is negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? You want to just memorize this. If you don't have it memorized, make sure you do so. There will be a quiz on that. You come back. So we're going to use this really quickly to solve one of these. I'm just going to model. And again, when you're using the quadratic equation, it has to be in the standard form, which means the entire quadratic must be equal to 0. So if you look at A here, it's not in the standard form. You have to move everything to make it 0. So I'm going to move everything to one side. Okay, here I go, moving it. So that's 0, and I get x squared plus 2x. It's the same problem, 35. So what I do now is I identify A, B, and C. So this is my ax squared plus bx plus c. So A is 1, B is 2, C is 35. Okay. Remember to take the sign with the number though. So for example, if we look at, let's look at another example here. So if we look at an example here, if this were your example, B, so A is 1, right? We're not solving this by the quadratic, but you could. B is negative 4. See the negative? So if the number is negative, take the sign, and then here C is 6, okay? So in this case, they're all positive, so it doesn't matter. So I write down the formula. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals. So x equals, and what we want to do then is you want to put parentheses around all of these things, is you're just going to plug in those numbers here, okay? So let's go ahead and do that. So x equals negative b, that's 2, plus or minus the square root of 2 squared minus 4 times a is 1, times c is 35, okay? all over 2 times a is 1. Now we simplify. X equals negative 2. This is going to go pretty long. I'm showing all the steps, but that's okay. Plus or minus the square root. That's 4 minus 4 times 1 is 4 times 35. What is that going to be? 120 plus 20, 140. Okay? All over 2. So x equals negative 2 plus or minus the square root. 4 minus 140 is going to be 136 negative, all over 2. Okay? And now what do we do? So x equals negative 2. And then what we have to do is we have to simplify this. So we go off to the side. And then we say, well, the negative comes out as I. Then I have 136. Now, oh man, how many copies of that? Okay, let's figure it out. What is that going to be? That's 2 times what? What is that? 72? 70, what? No. This is 65. Let's divide it. What is this one going to be? So that's 2. Let's just divide it out. Can't think right now. Okay. So it's going to be, what is that? 116, 86. Okay, sorry. 68. Okay, so it's 2 times 68. See, everybody gets caught up on something sometimes. That's 2 times, what is that, 34, and that's 2 times 17. Okay, so it's 2, 2, 2, and 2. So then I get I times, how many? There's 2, 2, 2, 2, and 17. There's only one group of 2. The index is 2. So I get 2I root. 2 times 17 is 34. I come back, that's what I stick in here, plus or minus 2I. Square root of 34 over 2. Notice, so I can't really add anything else to this. And here, all of these have a factor of 2. Okay? So what I'm going to do then is I'm going to divide each of them by 2. So notice, this does not, the 34 is not divided by 2 because it's inside the radical. So I get x equals, that divided by 2 is negative 1. That divided by 2 is I, square root of 34. Over 1. So x is negative 1. You don't need to write the 1 at the bottom. Plus or minus I root 34. Okay? So that's the single answer. You can write this separately as x is negative plus or minus, plus I square root of 34. And then x is negative 1 minus I root 34. So these are our 2 answers written separately. Okay? You can either write them like this or you can write them together. Just beware. You want to be able to recognize when they can be simplified. In this case, this is a complex number, we can't simplify it. Okay? These can be a little tough sometimes, just because it's a simplification, but overall shouldn't be too bad. Okay? And that basically covers it. That's the rest of the unit. So what you're going to do, please practice over here. Question B, question C, with using the quadratic equation. And let's go ahead and do D and E for good measure. Okay? And that basically covers it. And I will see everybody in our next class period. Have a good day.